So we have been working on in your class something really fun, and not just having kids turn and talk to unpack the misconception, but to have kids stamp the big idea, to remember what they need to do moving forward. So what's been the impact of that?
So I think looking at exit tickets, like the line that went throughout the lesson was factor out the GCF first if possible. And even on students who were low, I saw them try to plot a GCF. Some of them did it correctly, some of them did it incorrectly, but everyone tried to plot the GCF first, that's good. Like, it's good that they're recognizing that.
That's something we're going to look at later in it, but like just overall, what has been the impact of having kids like turn and say, what's the key thing?
I think like stamping these key points throughout the lesson is like, it's making kids actually remember and have like clarity on what are we learning today? What do I do in general, right? Like, they're not looking at every problem and going, I don't know how to start. They're saying, well, we've said this thing 3 times now, pull out the GCF, so I remember that's how I'm going to start.
Great, for that specific example. But I think just in general, it's a transferable skill. And I see, like, even on the paper today, Joseph had, like, his, like, key understanding in that box, and when you said go back to your notes, they all looked at the bottom of the box. So that's been really great. So today we're going to zoom in on factoring quadratics, because it's a foundational skill for this unit, but we know that's a part of a bigger standard, which is A508. And today we're going to zoom in on difference of squares and perfect square trinomials. So for this exit ticket, I'm sorry, I meant to have a piece of paper. What do kids need to know and show to show mastery? So usually we say know and do, but I'm kind of liking the language of show here. What do they need to know and show for this? You write it down for a minute, and then I have mine, and we can...
Sure. On this exit ticket? Okay.
Sorry, it's upside down. Awesome.
That's not the best little list, but
My list is not very long for this one. So let's start with show first, and then we're going to go to know.
Sure.
So what do students need to show?
They need to show, first, factoring out a greatest common factor. And they need to show it's kind of like they show that they're identifying it as a perfect square or difference of squares by showing the factors of a perfect square or difference of square.
Perfect, that's what I said. What about know?
They need to know how to identify a perfect square or difference of squares, and they need to know that factoring undoes multiplying, because if they know that, I mean that is what it is. It's like they need to know that that's what they're doing. It's like dividing compared to multiplying, and they need to know that so that they can check. Like, they should never get these wrong, because you can just quickly multiply and say, yep, this gives me the thing I started with, or no, it doesn't.
Right, and that's why I had you talk about the no second, because this is the big conceptual thing. So they need to know it's like the opposite of expanding.
Right.
So the way I sat here, and this is what I was hemming and hawing over before you came in, is thinking about like what is the conceptual definition of factoring, what we want kids to have, and what I landed on, and flip it over and let's write this down and let me know what your thoughts on it is. Factoring is like splitting an expression into multiplication of simple expressions. That's the first sentence. So factoring is like splitting an expression into a multiplication of simpler expressions. It helps us find out what you multiply together to get an expression.
Right. Can I add that I think the best definition I ever heard was like factoring is undoing distribution. This is distributing. Undoing that is factoring.
It's undoing, okay.
Which is like a skill that, like, that's how they learn to multiply polynomials.
That makes sense. There's also different ways we could say it. Do you think that will still help students understand that that factoring helps us determine all of the factors that multiply together?
No, I think yours is better for that. You said factoring is rewriting.
Factoring is splitting an expression into a multiplication of simpler expressions. The goal of factoring is to find out what multiplies together to get an expression.
To put that together, I'd say like factoring is splitting an expression into simpler expressions which multiply together. How did you finish that sentence?
I said the goal of factoring is to find out what we can multiply together to get an expression. And so why is it important for students like later on in math or in other parts of math to know?
So this is like super critical. This is something that they'll be expected to do pretty mentally for the rest of their mathematical career, all the way through calculus. It has tons of applications.
Give me one example.
The most prevalent that's going to come up this year is finding the zeros of a quadratic, which is actually like how projectile motion works, where something starts and where it lands.
Great.
Its home is in factoring.
Great. And so that's why, like, I know, like, I, for example, never learned why I was factoring and never had that conceptual understanding, but I think this is, if we zoom in here, it's going to have greater implications for the stuff you're going to do later in the unit later on. So just like knowing like the goal of factoring is to figure out like what are all the things that multiply together to get this expression, and later on we can use these simpler expressions for things like finding the zeros like you just said, or doing projectile motion. Okay.
That was my hook on this day, actually.
Great.
So we're on the same page here.
And sometimes maybe it's like saying that hook again.
Yeah, right. And just keep like that could be the line is like, remember, we're trying to find the things that multiply together to give us this expression.
All of the things. I think the key word is to say all of the things. And that's something sticky that I discovered when I was unpacking these. We were trying to figure out all of the things that multiply together. Okay, so I did not get an exemplar exit ticket from you, but I made one. And so I want you to talk me through how does my exit ticket meet the criteria for success?
You factored out the GCF and then showed that it's either a difference of squares, sum of squares, or not factorable further. Then you checked your work. How long did this take you?
5 minutes.
That's where I want to get. That's ideal, right?
I would argue that you're faster than I am. When we take the IAs, you know that I take twice as long.
I mean, I could do this very quickly. Students that, like, what I'm finding is that I don't think I know I'm digging into a problem, but, like, this is what I want right now, and I think we could change this right now. This would take students 20 minutes.
Right, so you have to give them more time. if you wanted them to also check their work, but that's like
Right.
something else. Maybe you next time don't have them check their work, but that's like something else. I think the key thing to zoom in on is here, and how does like this part meet those first couple of parts of criteria for success. So I heard you say I pulled out a greatest common factor.
Mm-hmm.
I ID'd whether it was difference of squares or a perfect square trinomial.
Yeah, you rewrote it in standard polynomial form. That was a mistake I saw a lot, students missing that step, which made it much more difficult. Right. So, yeah, I mean, you just went through and checked each one of these.
So what's the impact of having an exemplar like this?
Oh, it makes it clear what students need to do each time. I mean, to me, like what the key points are.
Exactly.
I have an exemplar.
I
didn't give it to you.
And I didn't see it in chalk either.
I did it by hand.
Okay.
I mean, I do have an exemplar on it.
Okay, so if you have
Exactly
one,
this.
great. Because as you just said, it like names the key points. Just make sure next time if you have one, just drop it to me. I wasn't sure if you had one.
Yeah, sorry, my bad.
That's all right. You have one though, so we can skip that whole part. Let's look at Paige's work though. So Paige is the one who got them all right.
Mm-hmm.
And so looking at Paige's work, what is missing? I would consider Paige like the student exemplar. So what is a difference between Paige's and mine? Let's disregard the checking work part for now.
Oh, okay. Just a lot of mental math. So, a couple things. Difference-wise, I look at like, she is not rewriting the expression with the greatest common factor pulled out here, like you did. She's doing that step mentally, which is good. It's like, that's where we want students by Algebra 2. This shouldn't be a step. This shouldn't be something they're showing work on by
Correct.
Algebra 2. So she's a little ahead in that regard, but I think that for most students, skipping this step is really hurting.
Right. So let's like look at, for example, Jamarco. And this student. So if you look at question 3 and 4 for this guy, well, actually all 1, 2, and 3 for Jamarco. And then question 3 here. What do you notice as a trend?
So, I noticed that they're like in this one, it's kind of like you can almost see their brain on paper. They wrote it and then they scratched it out. I don't know why they did that. It happens a lot. Or, like you can kind of see it in their heads of like what they're thinking. They're like, this is 2 times x squared minus 9, so I know that's x minus 3x plus 3. But they're like skipping it. And
right.
Here I see
When you say skipping it, what do you mean?
They're skipping writing out this step, 2 times x squared minus 9.
Right.
Well, this student did it, but scratched out. Then here, like they factor out this greatest common factor and think they're done. Because they're not recognizing like you can still factor that. I think they're not rewriting it. That's true here too. They pulled out that greatest common factor, which is a good sign. And then both of them got like, I don't know how to move on.
Right. I would say we do eventually want kids to be like Paige and do the mental math. However, we know that we are like remediating some skills that students don't have. And so they're not at a place yet where they can do the mental math.
Right.
So across all of these, like what is the first criteria for success that these students are missing?
Like rewrite the expression with the greatest common factor pulled out.
Exactly. So if we had to stamp that, what's going to be the highest leverage thing to address to build foundational factoring skills for kids?
After you factor out the greatest common factor, rewrite the expression.
Yes.
In standard polynomial form.
Yes.
If they put the n squared first, they probably would have gotten that right.
Yes, and that's I'm so glad you said that because look at this guy, right? Like this is a student who didn't get them all right, but I mean some beautiful work here, careful work of factoring things out, and this was just.
It's because they didn't write n squared first. That's where they went wrong because they're seeing -5 n times -2 and thinking it needs to multiply to give them the 10. If they just move this n squared up front.
But they're knowing at least to take this step of like.
This is great work. Until I saw Pages, this was like mine.
Right. Number 1 just made like one little mistake, and they should have said x squared inside instead of just x. But they show the best work.
And they know it. That's like with the factoring things. It's so much like conceptual. Which is, again, like with Dianya. She showed me she's pulling out the 2x. She forgets to write it. And it's like, that is wrong, but, like, you're showing me this concept, which is good.
Right. And Paige, again, doing the mental math, but we really, if we want them to understand this concept of all of the things that multiply together to make the bigger expression, we have to make sure they're pulling out this greatest common factor and rewriting the expression.
Yes.
So what is the student error and the conceptual understanding that it ties into?
I think students are looking at some of these expressions like 2, 3, and 4. All of these, to every single one of these, if you don't pull out the greatest common factor, are really difficult.
So greatest common factor is the error I'm hearing.
Hard to recognize. So like you've got to pull out the greatest common factor and rewrite that expression. By doing that, it will be easier to recognize the factors. Like you don't have to go from here to here. You should rewrite it. Like this should be the thing we show off.
And why is it important for them to pull out the greatest common factor and have all those parts? What conceptual understanding does that
It hits like
drive?
all the factors, right? So like 2x is a factor. It's part of what multiplies together to give us that final expression.
Yes. Okay, so let's write this down. This is what we're going to address in our reteach. And I got some materials ready to go. Told you I was moving and shaking. So students are skipping the step to factor out the greatest common factor, which show... Sorry, I'm going too fast. Students are skipping this step to factor out the greatest common factor, which shows that they don't fully understand that factoring is telling us all of the parts that multiply together to get a full expression.
Yeah, that sounds right.
By zooming into this more carefully, they're going to be more successful with this more challenging stuff you're doing later in the unit. Today, right? And so this is worth a quick little... You could take this chart paper with you for 5th period. What we're about to do will take 3 minutes.
Okay.
And you decide to cut something else. Okay, so since you are already doing this today and you did a little bit of work with GCF, we're going to do a guided discourse because I think it'll be more efficient. You don't need a full-on model. And we're just going to stamp those 2 things. The factor of the GCF, and we do it because we need to know all of the parts that multiply together to make this original expression. So we're going to do 2 rounds of practice. We're going to script out what you're going to say, and then you're going to do it. And then you're going to do it 5th period. I'm going to come watch.
Okay.
Cool. All right, so here is a little 1/4 pager I made on guided discourse. This is basically what you do in your class, but show 2 pieces of work. You're going to show one that's one that is like completely done, like maybe my exemplar, and then one that is missing that initial step. And ask like which one better meets the criteria for success. Poll the room, turn and talk, cold call strategically.
Okay. Can I ask a quick question?
Yeah.
Not trying to make an excuse, not trying to like pull it somewhere else. About 50% of the work was like mostly blank, and those aren't like really good for us to dive in data wise. Does that affect like whether you would choose to do guided discourse if like a lot of students are showing I don't really know?
Yeah, I usually do guided discourse when I have some students that have, when it's clear, I have a student who has clearly shown it and a student who is almost there so that students can see a clear difference between the 2. And I do a model when it's like nobody's even close.
Yeah, okay.
But
so you think this will be good even with students who like really are kind of missing most
the
of this?
mark, yeah, because they're still going to be able to see which one is like fully...
Okay.
Which one is fully broken down.
Great.
That makes sense? I think that guided discourse is the most effective in a math class. Like, when in terms of, like, you can do it most often, I should say, in a math class. You can do guided discourse. I'm working on one with Dr. Jones that's, like, it takes a long time.
Yeah.
Anyway, take a minute. What I want you to do is, over there, put the 2 problems you're going to do, and then on the right, write down what you're going to say.
Great.
And here's your marker. So what we want to do is like have the same problem, so that way students can see like the first one where they have pulled out the GCF and all of the work, and the second one where they haven't.
Sorry, I missed this. I thought you wanted me to come up with new practice problems and to do after they'd looked at the exit tickets. I missed that.
No,
so you want...
You do the same problem.
Got it.
Same problem. We have a new piece of
I misunderstood that.
No worries. That was my bad. So you do the same problem.
So you want it to be one of these problems that was on the exit ticket?
It would be easiest to. You might as well.
Is there a reason you wouldn't just make copies of that and have everybody look at 2 exit tickets side by side?
I think that like doing this way, like charting the error, is something that you can keep in your classroom as a reference point also, and it's just like.
Got it. Okay.
Because the thing we're zooming in here is like, how does one meet criteria for success? Like, which one better meets the criteria for success, and why is that important?
Sorry, wasting your time.
That's okay. It's alright. I'll get it later.
Okay. And I'm going to steal your...
I have mine here, if that's what you do.
Yep. I just need a I can write it down. So let's do number 2. That was the best example.
So I would do mine for the second one here, and then do pages for this.
Oh, you still want it to be correct?
Even though they're both correct, we want them to identify which one better meets the criteria for success and why.
Okay. Is that a parent? I've never heard him talk that loud. And you don't want to include the checking work part right now, or you do?
No, I don't think you should. This is the thing to zoom in on, because the gap was that they were not factoring out the grades cutting factor. Because I'm not understanding we need to know all the parts. You could even say, like, if you want to name, like, this is the work from a student who has the highest grade in the class. And it didn't meet the criteria for success, though. After, you know.
Mm-hmm.
So at this point, you'll pass by exit tickets. Kiddos have the criteria for success on the paper, and you're going to ask, like, which one of these better meets the criteria for success and why?
Okay.
All right, so you work on your script. Here's the little thing.
Can I make sure I'm understanding it all the way? So
yes.
We're passing by exit tickets, and my first point is going to be which one of these meets the criteria for success and better, and why.
Yep.
Try to talk to your party if 30 seconds go.
Yep.
They don't need 30 seconds because they're going to go 2, and then why.
Why is the big thing.
Why.
Mm-hmm.
Right, so stressing that in my question. Then, as they come back together, saying I heard everybody say no and why, and then more calling somebody.
To and why, yes.
Cool. And then is it like a stamp? So name for me, what are we going to do every time?
Mm-hmm. It could be a big idea or a key thing to remember. So sometimes it's a big idea and sometimes it's a key thing to remember.
I would say this is key, right?
It's both, I would say, right? So it's a pull out the greatest common factor, or always pull out the greatest common factor.
Right.
Because, why?
Makes the number smaller, as Journey said today. Which is
but it
true.
also tells us all of the parts that multiply together.
Right.
Without doing that, you might accidentally miss something.
Okay. And so then when they name that stamp, are we giving them another problem to try that's simpler? Is that the goal?
You can, yeah. Usually you would do that, but since this is right before you're doing this lesson on more factoring, then they'll have to do it for this.
I almost can. So here's something that I noticed today. I brought these X tickets.
Yeah.
This is part of it. So 2 and 4 are both perfect squares, and if they pull out the greatest common factor and rewrite it in standard polynomial form, they'll get both of these right just with this knowledge.
Exactly.
So today, what I would like to do is say, go to your X ticket for today. Which 2 can you answer right now?
I would tell them, answer 2 and 4 right now. Great.
There's half your X ticket done and correct. Good job.
Exactly. That's fine. Go work on your script.
Okay.
Because again, the first criteria for success on today's exit ticket is also factor out the GCF. We're going to stamp your idea.
And you would not ask this as a question. You would name it.
What do you mean?
So I could see this going.
You already asked it. That's when you're doing your cold haul, medium, high, low.
And so then I'm medium, high, low, and then I'm going to restate big idea, and I'm going to write it here.
Yes, and then you'll have it up on your wall.
And I'll say, so I want to make sure I say this really clearly.
Exactly.
Every time you factor, pull out the GCF, rewrite.
I think, hold up one second before you write in there. Pull out the GCF-Y. You're going into a procedure again. So pull out the GCF-Y.
So pull out the GCF so that we write all
of the parts, yep.
Factors and multiply to give the expression. I do want to
underline that word all.
I did.
Okay. All and why I think are the most important things to zoom in on.
Okay. I think it's important that we say rewrite it.
I do think that they
in standard form. Because that was something that
I think that they will do that.
If we just rewrite that n squared up front.
I think that they will do that. I do. And looking at the student work, they have like, they're good at like bringing it down. It's just they skipped that step.
I don't mean like just rewrite it. I mean this step here.
Mm-hmm.
That I saw missing from like, not all.
That's a more complicated question though, so I would hold on that. Yes, I agree, but I would hold on it and zoom in on just this GCF part for today.
Okay.
I would agree, but.
Can I still name it during this, like, we don't have to write it down, but even just naming, like.
It's gonna add extra words.
I'll just point. I won't say anything, I'll just like, and then we can, I don't want them to miss anymore. Anyway, okay, that's good.
Yeah, I would hold on it. Okay. I think that they're gonna get it.
Okay. And I'm gonna write that into the big idea place.
Yep, alright, so let's practice it real quick.
Then my fourth step would be turn to your X ticket for today, answer 2 and 4 right.
Yes, write that down so you don't forget. We can put this above your desk or something over the back of the room by your star charts during 5th period because I'm going to come in today. And I love how you said this. Answer 2 and 4. Like you were going to, this is great. You already got 50% right on your exit ticket. It's a great way to pump them up and make them feel successful in the first 10 minutes of class.
Right. Man, I wish I'd done this today for first and second hour. This is going to be really good.
Sorry. Okay, do it real quick.
Cool.
Teacher mode, action.
You all have your exit tickets back in front of you, and I've put up 2 responses for number 2 of your exit ticket. Which one of these meets the criteria for success best, and why? Good. Take 30 seconds, turn to talk to your partner, go.
Second one had more steps and they showed more work, they pulled out.
I'm hearing 2, why?
It's the greatest common factor.
Okay, so we come back and I go back with me in 3, 2, thanks for your eyes, mouths off in 1, okay, and pause.
Who's your medium kid in 5th period?
I heard 2, why? Let's hear from...
Medium.
I'm picturing second hour. Let's hear from 5th hour. Why am I struggling so much?
Well, let's keep going. We'll go back.
Let's hear from medium.
Okay, great. Then high, then low.
Right.
Okay, keep going.
That's bothering me. Okay. Medium, high, low. So I think that question sounds like why, medium, add on to that, high, stamp that for me, low. Great, so big idea.
So we've landed on a big idea.
So we've landed on this big idea.
Yeah. And then
every time you factor, pull out the greatest common factor first.
Don't write it yet because you can use this next period. Like don't physically write. Okay. I'm sorry, I'm interrupting.
Pull out the greatest, I was about to.
Yeah.
Pull out the greatest common factor first, so that we write all factors multiplied to give it an expression.
Because remember that. This will tell us this. Okay, and then what? What's the last thing?
Okay.
Turn
to your exit ticket for today. Answer questions 2 and 4. Let's start this day off with like half our exit ticket done and correct.
Nice. Perfect.